So now I will present the topology design of our project. There will be two branches, which are the Malacca branch and the KL branch. The Malacca branch is on the left hand side, while the KL branch will be the right hand side. So now I'll continue the Malacca branch first. There will be two routers connected to the cloud, which are the Malacca router 1 and Malacca router 2. Then Malacca router 1 will connect to a multi-layer switch 1, while the Malacca router 2 will connect to the multi-layer switch 2. Then in the Malacca, there will be three departments, which are the IT department, logistics department, and the sales department. And I allocated the IT department as the VLAN 10, and the logistics department as VLAN 20, and the sales department as the VLAN 13. According to the instructions, then we will only allocate two PCs in the topology. Yeah. Okay, so then each multi-layer switch will connected to the three department, and there will be cable connected to both the multi-layer switch 1 and multi-layer switch 2. These two cable is for the further development, which is for the HSRP configuration and also the ether channel configuration. So by doing the HSRP and the ether channel, we can prevent the system down of one of the devices, and the ether channel will help to make the Malacca branch become more efficient. Now we will come to the KL branch. KL branch will be one router connected to the cloud called the KL router. Then the KL router will connected to a KL multi-layer switch. Then the KL multi-layer switch will also connected to the three departments, which are the engineer department, finance department, and the KL and another sales department, which is located at the KL. So the engineer department will be the VLAN 14, finance department will be the VLAN 50, and the sales department of KL will be the VLAN 60. So this is the basic topology of our project. Then we will now further explain about the configuration of our topology. So this part we will focus on the basic configuration on the router and also on the switch. So take an example. In the Malacca router 1, when we want to enter the user mode, we have to key in the password. So now for the password, it is the called Cisco. Then it will come to the user mode. Then if we want to enable to go to the privilege mode, we enter the enable. Then it will require a password, and now the password is class. So this is the basic security configuration for the router. Then now we enter the show run. It will show all the information in these devices. So now in this Malacca router 1, the host name is Malacca router 1 exactly. Then we have put a service password encryption, so that all the passwords shown here will be encrypted. So like this enable, so it will already encrypt the password, like so that others cannot view directly for the password. And this is another password called the admin secret. Now in this part we only focus on the basic configuration, so we can just navigate to the below part. Right. We have also put a banner called authorized access only. We also have configured the transport input SSH, as the SSH is more secure than the telnet. So this is for the basic configuration of the router. Now we come to the multi-layer switch 1. So now I have already go into the privilege mode, and I'll type the show run. So it also have the service password encryption and hostname Malacca multi-layer switch 1 and the encrypted password. So this is for the DHCP. We just go through it. Then another encrypted password. Then this is for the SSH configuration. And go to the below part. This is there's also a banner configure and the transport input SSH. So this is for the basic configuration of the router and the switch. Okay, so I have put some number here like 2054420. This is for the VLAN for between the multi-layer switch 2 and Malacca router 2. Like the Malacca router 2 have a 2054421, and while the Malacca multi-layer switch 2 will has the 20.44.2.2. So they will have two different IP but in the same subnet. So it will help the communication. And in the Malacca router 1 and Malacca multi-layer switch 1, they'll use the 205.44.1.0, and the Malacca router 1 has the 205.44.1.1 on the gigabit Ethernet 001, while at the Malacca multi-layer switch 1, it will have the 205.44.1.2 at the gigabit Ethernet 101, so that can communicate to each other as they were in the same subnet. So here is the 205.44.3.0. This is for the communication across the cloud. So the Malacca router 1, Malacca router 2, and the KL router will use this subnet. So Malacca router 1 has the 205.44.3.1 on the serial 010, while the Malacca router 2 will have the 205.44.3.2 at the serial 010. Lastly, the KL router will has the 205.44.3.3 on the serial 010. So this three serial port of the Malacca router 1, Malacca router 2, and KL router are in the same subnet so that they can communicate across the cloud. Okay, so this is for the basic configuration of the router and the switch. So now I will show the VLANs part and the trunking. So basically we have already do VLAN for the Malacca and the KL branch. So at the Malacca there will be VLAN 10, 20, and 13 for the IT department, Logi department, and the sales department respectively. While at the KL there will be VLAN 40, VLAN 50, and VLAN 60 for the engineer department, finance department, and sales department at KL respectively. So now let me show the VLAN information. We will use the show VLAN brief. So by keying the show VLAN brief, we can view that VLAN 10, VLAN 20, VLAN 13, and the VLAN 99 is for the native VLAN, and this VLAN 999 is for the security use. Like we have already put all unused ports here. So this basically is the VLAN information. Now we will use the show interface trunk. So this is all the trunk that we configure on this Malacca multi-layer switch 1. So the trunk has already configured from the Malacca multi-layer switch 1 to the IT switch, logic switch, and sales switch, which is the gigabit 102, 103, and 104. There's also a trunk called a PO5. This is for the trunk between the multi-layer switch 1 and multi-layer switch 2. And this is called PO5 because they have already been configured as the Ether channel. So this is the trunking of the multi-layer switch 1. I will take for the show port level. So can become more easily to view the ports information. Like now we come to the multi-layer switch 2. I've already entered the command for the show interface trunk. So there is also a PO5, gigabit 102, 103, and 104 configure trunk. So this is for the 102 to the IT switch, gigabit 103 to the logic switch, and 104 to the sales switch. And the PO5 is for the trunking to the multi-layer switch 1. So password Cisco, enable password class. Now I will show the trunking of the one of the access switch, which is the sales switch. Let me show VLAN brief. Sorry, typo. So at the sales switch, there's also VLAN 10, VLAN 30, 20, VLAN 13, and the VLAN 99 for the native, and VLAN 999 for the unused ports. Then now enter show interface trunk. So, and at the sales switch, there are only two cable connected, which is the gigabit 01 and gigabit 02 connected to the multi-layer switch 1 and multi-layer switch 2. So there's also definitely configure the trunk so that they can communicate to each other. There's also one show interfaces. Status. Show interface status. So this is all the interface information. So we can view that as the sales department has 8 people, so there will be from the FA01 to FA08 will being allocated to the VLAN 13, and other ports that are not connected will be disabled and put to the VLAN 999. So as there are only 2 PCs put, so we have put only 2 PCs, so the FA01 and FA02, the status is connected and they are in VLAN 13, and others, as there are no PC connected, so the port is show no connect. But as we put a new PC and connected to the port, it will change the status. So this is the trunking and VLAN information of the Malacca branch. So now we come to the KL branch. We will now enter the show VLAN brief. So there are no VLAN configure as all the VLAN are connected to the multi-layer switch, and then the multi-layer switch will pass the packet to the router. So only the trunk will be configured from the multi-layer switch to the router, but the router will not have trunk to the multi-layer switch. So let me show the information of the multi-layer switch. So I will show VLAN brief first. So at the KL multi-layer switch, there will be VLAN 40, 50, 60, and 99, which is for the this is for the engineer department. VLAN 40, VLAN 50 is the finance department, and the KL sales is the VLAN 60, and 99 for native, and also 999 for the unused port. So another command, which is the show interface trunk. So at the multi-layer switch, the gigabit 101 is to the router, 102 to the VLAN 40, 103 to the VLAN 50, and the 104 to the VLAN 60, and all allow the VLAN 40, 50, 60, and 99. Okay, so another show the interfaces status. Okay, so there are only 4 gigabit Ethernet connected, so it will show status is connected and all are trunk, and other ports that are not used will be disabled and moved to the VLAN 999. Now we come to the access switch of the engineer department. So there's also the VLAN information, the 40 for the engineer, 50 for the finance, 60 for the sales, and 99 and 999. And we come to the show interface trunk. So the trunk will only being configured on the gigabit 01, which is the cable connecting from the access switch to the multi-layer switch, and it allows the VLAN 40, 50, 60, and 99. And for the interface status, so only 2 PCs connected, so the FA01 and FA02 is connected, and other are disabled and moved to the 999. And the gigabit 01 is the port connected to the multi-layer switch, so it is connected and it is trunk. So this is for the status of the ports for the access switch at the KL branch. Well, we come to the inter-VLAN routing part. So for the inter-VLAN routing, there will be 2 ways we use in this project, which is one is using the multi-layer switch and another one is by using the router on stick. So we have already done the inter-VLAN routing using the multi-layer switch at the Malacca site, and at the KL branch we have to the router on stick. So let's see about the inter-VLAN routing information. So this is the show run. After we key in the show run, this is all the information, and we now come to here, which shows the interface VLAN 10, VLAN 20, and VLAN 30, and also VLAN 99. So for the VLAN 10, the IP address is 205.44.10.1 and 255.255.255. Then for the VLAN 20, it has the IP of 205.44.20.1, and VLAN 30 205.44.30.1, and VLAN 99 is 205.44.99.1. So if the PC want to travel from one VLAN to another VLAN, they has to pass through the multi-layer switch. So like the PC at the VLAN 10 will use the VLAN 10 in this multi-layer switch, which is the 205.44.10. This is the multi-layer switch one, sorry. So the PC at the VLAN 10 will use the 205.44.10.1 of the VLAN 10 in the multi-layer switch 1. So there's also the same configuration for the multi-layer switch 2, but the IP will be a little bit different. Like in the multi-layer switch 1, the VLAN 10, VLAN 20, and VLAN 13, they'll use 205.44.10.1, and in the multi-layer switch 2, it will use the IP of 205.44.10.2, which is in the same subnet but different IP, so that it will not confuse. Then also, this is for the inter-VLAN routing using the multi-layer switch 2. Then in a KL router, we have used a router on stick. So if we put the mouse cursor on the KL router, it will shows the gigabit Ethernet 001.40.50.60 and .99. And so the PC at the VLAN 40, 50, and 60, they will they will not use the multi-layer switch as in the Malacca branch. It will use the KL router to do the to do the packet transfer from the one VLAN to another VLAN. So let us go to the information. This is also the information from the show run, and here is the information. So for the router on state, the VLAN will be sub interface in the gigabit Ethernet 001. So gigabit 001.40, we will use the encapsulation .1Q40, and the IP address will definitely be the 205.44.40.1 as it is in the VLAN 40, so here will also be the 40. So for the VLAN 50, then 205.44.50.1 encapsulation .1Q50, and the 60 is VLAN 60 has the IP address 205.44.60.1, and the 99 for the native we have the IP address 205.44.99.3. 99.1 is at the multi-layer switch 1, and 99.2 is at the Malacca multi-layer switch 2. So here KL branch will have a 205.44.99.3. So this is for the inter-VLAN routing for the Malacca branch and also KL branch. Let us do a small test. So we will ping from the VLAN 10 to the VLAN 40. So let us see one of the IP of the PC from the VLAN 40. So we will ping from the VLAN 10 to VLAN 40 using the ping 205.44.40.2. Let us see. If it is success, it means the inter-VLAN routing is completed and can run for the system. So it is normal that it first request timeout, and we try again, it will get a completely receive 4 packets. So from this test, we can now confirm that our inter-VLAN routing is completed with the help of the OSPF and other routing ways. So in our project, we will use the OSPF, and it will be further explained in the other parts. So it is not a very efficient way as for us to configure an IP for each devices. So normally we will use a DHCP, so that the DHCP server can help to allocate the IP automatically when we open the packet. So now I will present the DHCP that we configure in our topology. So at the Malacca department, we configure the DHCP server at the multi-layer switch 1, while at the KL we configure the DHCP server at the KL router. So as we configure the DHCP server in the multi-layer switch and KL router, but not at a server, it will become become easier, as if we use the DHCP server, we might need to use the DHCP relay agent. So now let us show. So now I will change from static to DHCP, so it will show the DHCP request successful, and we get the DHCP and we get the IPv4 address so we get the unique IPv4 address. So let us see the DHCP server information. We have used a show IP DHCP pool. So for the VLAN 10, we can show that it has already release two address, which is for the two PCs in the VLAN 10. Then we come to the VLAN 20 is also released two address, which is for the two PCs, and also same for the VLAN 30. So this is the like a summary. So for the VLAN 10, it has a current index of 205.44.10.1, which is the IP for the VLAN 10 in this multi-layer switch 1, and it can release the range from the 10.1 to 10.254. So, but when we configure this DHCP server, I will run again for the show run so that we can know the information. So for the IP DHCP, we can view that we have already excluded the address for the like router and multi-layer switch that already configured, so that when the PCs request the IPv4, it will not release the IPv4 address of the router and also multi-layer switch that we manually configure. So like in this situation, we have already excluded the 20.44.1.1, which is the IP address of this marker router 1. 205.44.1.2 is the address for the multi-layer switch 1, and this 205.44.2.1 is IP of the marker router 2, and 205.44.2.2 is definitely for the multi-layer switch 2. So 3.1 is for the serial of the IP for the port serial port of the marker router 1. Then this is for the serial port of the marker router 2. This is for the serial port number of the KL router to the cloud. So this all IPv4 has already been excluded, so that it will not get the duplicate IPv4. Okay, so now exit the show run and we go to the show IP DHCP binding. So by entering this show IP DHCP binding, we can view the information of the IP address that this DHCP has already allocated. So like this 2044.10.4 and 2044.10.3 is definitely for the VLAN 10. So the 205.44.10.3 is for the PC1, and 205.44.10.4 is for the PC2. So this is for the VLAN 20. So VLAN 20 is 205.44.20.3 and 205.44.20.4 for the PC2 of the VLAN 20. Sorry. So this is all the 6 IP address that being allocated from the DHCP server to the PCs. So now we come to the KL router. At the KL branch, the KL router is configured as the DHCP server. So let us see the information. Let's just use the show IP DHCP pool. So same for the VLAN 40, it has already released the 2 address for the 2 PC in the VLAN 40. So also 2 release address for the VLAN 50 and 2 address for the VLAN 60. Also at the show run, we have already excluded the address like 205.44.40.1. This is for the router on stick address. So this is the address for the VLAN 40 to pass through, and this is the IP address of the VLAN 50 to pass through, and this is the VLAN for the VLAN 60. So let us can view more clearly. So this is we have already excluded this address, like 205.44.40.1, 50.1, and 60.1. This is another 205.44.3.3. This is for the serial port for the KL router to the cloud. So this is also being excluded. So this show how the DHCP is being configured. So like we can change static and DHCP again so that it will request again for the DHCP. So this will really become efficient, especially for the scalable network, so that the administrator will not need to manually assign the IPv4 to each devices. Okay, so now we come to the frame relay part. So frame relay is especially used for the Malacca router can pass through the cloud and go to the KL router so that the Malacca branch and the KL branch can communicate to each other. I just assume the Malacca router 1 as the number 1, router 2 as the number 2, and the KL router as the number 3 so that it can be easier to understand. So at the cloud, so as the Malacca 1 connected to the cloud using the serial 0, the Malacca router 2 connected to the cloud using the serial 1, and the KL router connected to the cloud using the serial 2. So at the serial 1, which is the port connected to the Malacca router 1, I will put the DLCI as 103, which means the Malacca router 1, which has the number 1, connected to the KL router, which has the number 3. So it is called 103. So the name is to KL router. So at the serial 1 is the port connected to the Malacca router 2. It has a DLCI 203, which means 2 connected to 3, and the name is also the 2KL router. So at the serial 2, which is the port connected to the KL router, it must have 2 DLCI, which is one is for the KL router to the Malacca router 1, and another one is KL router to Malacca router 2, so that the frame relay can be configured successfully. So there will be 2 DLCI, which is 301, which means 3 connected to 1, and another is 302, 3 connected to 2. So this is 301 has name of to Malacca router 1, and 302 have the name of to Malacca router 2. So after configure the interface serial 1, serial 2, and serial 0, we come to the frame relay, and we have already added the frame relay, which is the serial 0 from the Malacca router to KL router, and serial 2 from the KL router to Malacca router 1. So this is the first line, and another one is the serial 1, which is the Malacca router 2 to KL router, and another is the serial 2, which is the KL router to the Malacca router 2. So this is another line, so that both the Malacca router can connect to the KL router, and KL router can communicate to the Malacca router 2. So after configure the frame relay at the cloud, we also have to configure at the Malacca router 1. So as this is the document, go to the frame relay. So like as the Malacca router 1, we have to go to the interface serial 010, which is the port connected the Malacca router 1 to the cloud. We have to enter encapsulation frame relay and frame relay map IP. So this frame relay map IP, this is the IP of the KL router, and this is the DLCI 103 from the 1 to 3 broadcast, and we have to no shut so that the interface will not shut down. So this is also for the Malacca router 2. So Malacca router 2 at the serial 010 interface, encapsulation frame relay mapped to the KL router at the DLCI is 203 that we configure at the cloud. So at the KL router, there will be two frame relay map. One is to the Malacca router 1, one is to the Malacca router 2. So the DLCI is 301 and 302. So after we have configured the frame relay, let us view the frame relay information. So like I key in the show frame relay map. So for the Malacca router 2, it shows the 01010. It is in the status up, which is functional, and it will map to the IP 205.44.3.3. This is the IP of the KL router. DLCI 203 from the 2 to 3 broadcast. So when this shows up, it means the frame relay is successfully configured. So let's come to the Malacca router 1. Show frame relay map. So this is the frame relay status of the Malacca router 1. It also mapped to the 205.44.3.3, which is the KL router. Their CI is 103 broadcast. Now we come to the KL router. So it should have two frame relay, which is to the one is to the Malacca router 1 and another one is Malacca router 2. So this 205.44.3.1 is to the Malacca router 1, have the DLCA 301, and another one is 205.44.3.2, which is to the Malacca router 2, and it has the DLCI 302. So after the frame relay is successfully configured, we can try to ping to them. So like 205.44. 3.1. This is to the Malacca router 1. So it shows the success rate is 100%. It means that it successfully pinged from the KL router to the Malacca router. So this is for the frame relay. For the ether channel part, we have already configured the ether channel between the multi-layer switch 1 and multi-layer switch 2 in the Malacca department. So to do the ether channel, we have to first configure trunk between the multi-layer switch 1 and multi-layer switch 2, and like we stated before. So now we will go to view the information of the ether channel. So this is Cisco password class, show ether channel summary. So we can view for the ether channel, we have configured this is a group 5 and port channel 5. Then we have used the protocol LACP, and the ports included in the ether channel is the gigabit 105, gigabit 106 between the multi-layer switch 1 and multi-layer switch 2. So by using the ether channel, so there will be more efficient, and the port will and the devices will function faster because they have a higher bandwidth. Yes. So this is for the ether channel.
All right, now for the HSLP. So the HSLP in our network, we configure it on the Malacca area on these two multi-layer switch. All right, so what is HSLP? HSLP act like a backup switch. So for example, if one multi-layer switch fail, the other multi-layer switch will take control of the network trafficking. So it provides fault tolerance. All right, now to verify that the hash SLP work, we first will need to ping from the market area to KL area. So for example, I'm going to ping from the VLAN 10 to VLAN 40 over here. So first we need to see its IP, 205, 44, 40, and 2. Now we go to this PC, 205, 44, 40, and 2. Give it some time because the first time pinging usually takes quite some time. All right, now we ping again. All right, now that we can know that the ping is successful, now we need to know the route that this PC takes for its network to go to from KL and from Malacca to KL. So to do that, we need to use trusted and to the destination IP. Sorry. All right. So this four IP is the route that this PC takes from Malacca to KL for its networking traffic. All right. So the first one, the first route, the first IP is the 205, 44, 10, and 1, which is this multi-layer switch one. So for over here, go have a class show IP interface brief. All right, so as you can see over here, this one, the VLAN 10 over here, this is the IP that this PC take first. The root, the first IP in the root. All right. Now, after that, you will go to this router because this router is directly connected to the multi-layer switch. So do the same again. Interface brief. All right, as you can see, 205, 44, 1.1. All right. After that, you will go to this KL router over here. So the IP go. So the IP for it is 205, 44, 3.3 because it's at this 010 port. If you go check here, yep, 205, 44, 3.3. So, and then the last IP is going to be the destination IP, which is 205, 44, 40, and 2, which is this PC over here. 205, 44, 40, and 2. Yep, so its route is from this PC to this multi-layer switch, and then to this router, and then to this KL router, and lastly to this destination PC. This is the route. All right, now we're going to verify that the HSLP is working. So before I verify that, I am going to show that which multi-layer switch is active and which multi-layer switch is standby. So to do that, we're going to type show standby brief. Okay, as you can see here, this multi-layer switch 2 is on standby state for every VLAN. And this multi-layer switch 1 show standby brief. All right, it's active for every VLAN. All right, so to verify whether the HSLP work or not, first we're going to cut the cable off. After cutting cable, we also need to shut down the VLAN. This is because after cutting the cable, the SVI, the switch VLAN interface, will still think that it is connecting or operating. So we need to shut it down for the HSLP to work. So to do that, first config T, interface VLAN 10. After that, we're going to type shutdown. We're going to shut it down manually. All right. After you shut it down, we can go over here and wait a few seconds. Yeah. And then this over here is going to turn from standby state to active state. So tap again, show standby brief. Yep, as you can see here, the VLAN 10 in this multi-layer switch 2 will become from the standby state into active state because the VLAN 10 in this multi-layer switch 1 has failed. So HSLP will take effect and make this multi-layer switch 2 to become the active switch. So now we're going to now we go back to this PC and test the pinging. The pinging can still work. And now we check the root detects. The root will be different because this is now the active. This is now the active switch, and this become the standby switch. So let's see. So the first IP for is so the first IP in the root is 4410.2, which is the IP for this multi-layer switch 2. So show IP interface brief. As you can see here, the VLAN 10 in this switch is exactly 4410.2, and after that you will go to this router because they're connected to this multi-layer switch 2. So go plus show IP interface brief. Sorry. All right. So let's see what port it used. 001. So 001 port is 205 44 2.1. Now let's go back to this PC. And yes, the second IP in the root is 205 44 2.1. Okay. Now after that, you will also go back to this KR router and lastly onto this PC. So as you can see, it's going to be 205 44 3.3 over here. Yep. And then last one is still the destination 44 40 and 2. Okay. So it's basically switching from this bottom multi-layer switch and the router up to this multi-layer switch and router. All right. Now that we have verified that the hash topic work, we are going to make the switch back to its original, which is turning this back this multi-layer switch 2 back to the standby state and this multi-layer switch 1 back to the active state. So how to do that? We're going to connect back the cable, and we're going to the VLAN 10 and we're going to open it again. Bye. No shutdown. All right, now that is back to the active state, and then you will see that the HSLP will make this multi-layer switch from standby back to active state back again. And the multi-layer HSLP will make this multi-layer switch through from the active state back to standby state again. Show standby brief. All right, this now from the active over here, active, and back to the standby. All right, now why would this happen? So this will happen because of we configure something called preemption. It's like setting a priority. So show standby brief. Okay, sorry, show standby. So as you can see over here, the VLAN 10, the preemption is enabled and the priority is 100 is the default. So remember this. And over here, show standby. Show standby. All right. So for this VLAN 10, the preemption is enabled and the priority is 150. We configure it because the default is 100. So what this does is the HSLP will find the switches that have cable and with the highest priority to make it the active switch. So just now, originally this one is the active switch, but then we cut off the cable and shut down the VLAN, which means this the lower one, which the lower priority one, which is the 100 one, because it's the only switch left, so it become the active switch. And now that we have connected back the cable and opening back the VLAN 10, the HSLP detect that there is another higher priority than 100. So it make the highest priority become the active switch, which is Maka multi-layer switch 1. And yeah, that's all for the HSLP of our network. All right, now for the OSPF of our network, we configure it over here at the marker area with the two multi-layer switches. So what does OSPF do? OSPF allows switches to connect to each other and share their routing information with each other. All right, so let's start with the multi-layer switch one first. So let's type show IP OSPF. All right, this multi-layer switch one have a router ID of 1.1.1.1 and is with the process ID for 10. All right, so if we go into deeper, show IP OSPF interface brief. All right, we can see that this this multi-layer switch has four different interfaces. So for the we can go with the three at the top first, the VLAN. So yes, three different VLAN with different IP. All the VLAN are in the same process ID of 10 and in the same area of 0, but the IP is different, like 205 44.10.1, 205 44.20.1, 205 44.30.1. So through this, we can know that this VLAN 10, this VLAN 20, and this VLAN 30, and they all have the subnet of 24, and they are all in a designated router state. So over here, we can see that the neighbor is 0/0. What this means is that all of these VLAN are passive interfaces. All right. Now over here to the fourth interfaces, which is the Gigabit Ethernet 101. It's also in the process ID of 10 in the area of 0, and the IP address is 205.44.1.2 with a subnet of 24, and is in a backup designated router state. All right, now if you type show IP OSPF neighbor, we can see that the neighbor ID is 2.2.2, and the address of it is 205.44.1.1. And the interface it used is Gigabit Ethernet 101. So over here, Gigabit Ethernet 101 will connect to this. And so this will be the neighbor ID that is mentioned, 2.2.2. So we can check it like by going over here and type show IP OSPF. And yep, the ID is 2.2.2. All right, and if you want to check the interfaces or the address of it, we can type show IP address. Okay. Show IP interface brief. Sorry. Yep. All right. Now we can see this one is Gigabit Ethernet 001, and the address is 205.44.1.1, and you can see it. Yep. Gigabit Ethernet 001, and the IP is 205.44.1.1. All right, using the same concept, now if we show IP OSPF neighbor, all right, you have two neighbor ID, which is 1.1.1, which is this multi-layer switch one that we just stated earlier. Over here, the ID is 1.1.1, and then this has 5.5.5.5, which is over here to this cloud PT, because it uses 0.0/10. 0/1/0. All right, now go back to this multi-layer. We want to do the second multi-layer at the market area. So with the same configuration, show IP or SPF. And now we can see this. We can see that this one have the router ID of 3.3.3.3. All right. Now show IP or SPF interface brief. All right. Now we can see that this also have four. This has four interfaces. So we're gonna start with the bottom three first, which is the VLAN. Okay. So again, these three VLAN are in the same process ID and the same process area, but with different IP address, which is 44.10.2, 44.20.2, 44.30.2. they are, which means this one is VLAN 10, VLAN 20, and this one is a VLAN 30. They all use the subnet of 24, and they are in the designated root state, and their neighbors is also 0/0, which means they are also passive interfaces. All right, and over here we got a interface of Gigabit Ethernet 101, which means 1/0/1, and yes, the process ID of 10 and the area of 0, and the IP address is 205.44.2.2 and uses 24 something of 24, and it is in the backup designated router state. Right, now if we type show IP OSPF neighbor, all right, this is the neighbor ID, which is the 4.4.4.4, and you can see that the IP address of it is 205.44.2.1, and it's using the Gigabit Ethernet 101 to reach this neighbor. So let's see Gigabit Ethernet 101 to reach this neighbor, and it will be this one, the router. So to confirm it, we can go over here and type, and we type show IP OSPF. All right, the ID of it is 4.4.4, which is the same one if over here, and then we can also type show key interface brief. Yep, and then over here using the Gigabit 0/0/1 interfaces, we can see it also have the IP address of 205.44.2.1, which is the same over here. All right, now with using show IP OSPF neighbor, we can see that you also have two neighbors with the neighbor 3.3.3.3 leading to this multi-layer switch 2, because we just state the ID of it earlier over here. And over here using the serial /0/1/0 interfaces, it will lead to the neighbor ID of 5.5.5.5, which is this cloud over here, because over here is a serial 0/1/0 interfaces. All right, and that is about the OSPF of our network. All right, now for the endpoint security and the access control on our network, we have done some security configuration on all of the multi-layer switch and the access switch. So, for example, on the multi-layer switch, we done security configuration such as manually close the unused ports and put them in uncommon VLAN. So, for example, as you can see over here, these are the unused ports starting from 107 until 114. We manually closed it. After that, we put them in uncommon VLAN. In this case, we create a VLAN 199, and then we put all the unused ports in over here. So we done this for all the multi-layer switch in our network. So for example, over here. These are unused ports, and then manually close it, and then we put it in uncommon VLAN, like right here, and on KL area also. And yep, this is the same for KL and Malacca, which is manually close the unused ports and then put them in uncommon VLAN. All right. After that, for the access switch, we also done the same thing, which is close the unused ports. So P interface brief. Yeah, manually close the unused ports and then put them in the those uncommon VLAN. Show VLAN brief. in this case is 015 until 024, which and then we manually close it and then we put it in the uncommon VLAN. All right. After that, we also we also enable port security on the access switch. Okay, what port security does is it put like a restriction on the MAC addresses. So for example, show port security. All right, so we configure that all the ports on this switch can only have one maximum MAC addresses at a time. Over here, the MAC security address only have one at a time. And then what happens if this rule is violated? If this rule is violated, the security action will be taken is the port will be shut down. Yep. After that, we also configure port security sticky. So what this does is that the access switch will automatically get the MAC address that the port is connected to. The access switch will automatically obtain the MAC address of its port that is connected. So for example, the 01 port is connecting to this access switch, right? So yeah, the access switch will automatically obtain its MAC address. So we configure this for all of the access switch on our network. So I'm gonna show a few as example. Show IP interface brief. Manually close all the unused ports and put them in uncommon VLAN. After that, also port security, and also make them all port security sticky. I'm going to show a few examples. So IP interface brief. Manually close the unused ports. After that, put in some uncommon VLAN and also port security. And also make show port security, make it sticky. So we'll automatically obtain the IP. So the access switch will automatically obtain the IP addresses of the device that is connected. Yep, and that's it. And that is some of the security features that we configured for the access switch and the multi-layer switch. So now for the STP. So in our network, we configure STP on every multi-layer switch and every access switch. So what does STP do? STP is used to prevent loop in our network. So starting with the market area on the multi-layer switch. As you can see over here, it uses mod PVST for the STP, and it is for VLAN 10, 20, 30, 99, and the priority is set to 0. And for the multi-layer switch 2, multi-layer switch 2 also uses mod PVST, and it is for VLAN 10, 20, 30, 99, but the priority is 4096. So what does the priority do? The priority is used to determine the root bridge. and the root bridge is determined with the determined by the one of the lowest priority. So in this case, is the multi-layer switch one, because multi-layer switch one has priority 0, which is the lowest one. So the same is also for the KL area. So over here. So over here, the KL area, the STP users is mod. The STP mod users is rapid PVST, and it is for VLAN 40, 50, and 60 because the KL area you use VLAN 40, 50, and 60. And the priority is set to 4096. But because this is the only switch multi-layer switch days, and so the priority, this will be the lowest priority because there's no other multi-layer switch, and so this one will be the root bridge. So now for the access switch, okay, as we can see, it uses the STP mode rapid PVST, and to every active port, we apply, we configure STP port fast and STP BPDU guard. So what does BPDU guard do? So the BPDU guard will shut down every port that receives the BPDU if the port is set to port fast. So for every active port, we have applied port fast and BPDU guard. All right. Now, so this is applied to every access switch in our network. So I'm gonna show a few. As you can see, we have PPVST and configure port fast and BPDU guard. It's the same for KL area also, repeat PVST, and also port fast and BPDU guard for active ports. And yeah, that's it for our spanning tree protocol in our network. All right, now for the DHCP, ALP, and STP attack prevention, we have also done some security configuration on our network. So for example, in the multi-layer switch, we have done like DHCP snooping and also dynamic ALP inspection. So for example, for the DHCP snooping, as you can see over here, this DHCP snooping is done on this 3 VLAN, VLAN 10, VLAN 20, and VLAN 30. Also, we have disabled the insertion of option 82, and we also put some of the interface to be trusted interface, as you can see over here. So what does trusted interface do? Trusted interface allow them to send responses to the DHCPs. All right. Also, we also have done dynamic ARP inspection. It's also done on VLAN 10, VLAN 10, 20, and VLAN 30. Also, it has some trusted interface as well. And both of these security configuration is done on all the multi-layer switch and the access switch. So I'm gonna show very fast. Hey, sorry. As you can see, these are the DHCP snooping on these are the VLAN that the DHCP snooping is enabled. The insert option 82 disabled, and these are the trust interfaces. And these are all the dynamic ARP inspection enabled VLAN 10, 20, and 30. All of the configuration are done on all the multi-layer switches and the access switches. Over here, the VLAN enabled for the DHCP snooping and the dynamic ARP inspection is 40, 50, and 60. Because over here in the KL area, we use 40 and 50 and 60 VLAN. All right. Now for the access switches, we also done the same, which is the DHCP snooping and the dynamic ARP inspection. So as you can see, these are the VLANs that the DHCP snooping is enabled. The insert option 82 is disabled, and these are all the interface that is trusted, and these are the interface that we don't trust it. So as I said, the trust interface can send responses to DHCP. Or we also configure ALP inspection also. I'm going to show a few since we have configured them on all of our access switches. So for here, show IP DHCP, because it's a KL area and we use it VLAN 40, 50, and 60. So the VLAN number over here for the DHCP snooping is 40, 50, and 60. It also applies for the dynamic ARP inspection. Yep, as you can see, VLAN 40 and 50 and 60 is enabled for the DHCP snooping and the dynamic ARP inspection over the KL area. Yep. All right. So in conclusion for this part, so all of the multi-layer switches and the access switches we have configured with the IP DHS with the DHCP snooping. This DHCP snooping is used to like prevent rogue server attack, and we also configured dynamic ARP inspection is to prevent against ARP spoofing. All right.